Hello and welcome to the EWJI webinar according to the topic Performance Requirements of Water Blasting Hoses. My name is Patrick Schlappner and I am working as a product manager at SPIR STAR AG in Germany. Mr. Levin from Parker will also be a speaker today. In the first step, we want to give you an overview about performance requirements on high-pressure hoses according to the EN 1829-2. Here we will answer the following questions. How many different tests are required? Are there test requirements for the hose type qualification? Which tests need to be performed with every hose assembly? In the second step, Mr. Levin will inform you about the testing requirements of the ISO 23384. He will answer the questions. What are the differences of the new ISO 23384 from EN 1829-2? What are the test requirements for type qualification and which tests shall be performed with every hose assembly? As you know, there are a lot of risks in high-pressure applications. One risk is the bursting or failure on hose assemblies. The escaping stream of liquid can cause physical damages, but also the whipping can be a dangerous manner. Additionally, it's also risky to have a failure in connectors. Also here, the escaping stream of liquid can cause physical damages, and whipping could create problems as well. Errors by the operator can also be a risk. For example, if end users use hose assemblies with too high pressures. The change in length could also create problems. Because with the changing length under pressure, it could be that the hose lose their hold. Because of all these risks, EN 1829-2 were implemented to define standards to avoid an incorrect handling and to minimize potential hazards. But what is EN 1829? EN 1829 is a European standard which includes safety requirements for high-pressure water jet machines, hoses, hose lines, and connectors. The first part, 1829-1, is the standard for water jetting machines. EN 1829-2 is the standard for hoses, hose lines, and connectors. This standard defines test requirements for high-pressure hoses. All in all, the following requirements are defined in EN 1829-2. Compatibility of components. That means that hoses and fittings have to match each other. Mechanical requirements. Here, all components, hoses and fittings, shall not fail under the maximum working pressure. For hose lines with maximum allowable working pressures up to or equal 3000 bar, the safety factor have to be 2.5 to 1. Hose assemblies with a maximum working pressure over 3000 bar have a safety factor 2 to 1. Also, thermal requirements are defined in this standard. They say hoses or hose lines should have an operating temperature between -10 degrees Celsius up to 70 degrees Celsius. Additionally, we have the change in length. Any change in length shall not exceed ±2% of the original length. According to the tensile strength, hose lines shall withstand a tensile force equivalent to that indicated by a pressure equal to 1.5 times the maximum allowable working pressure, or 2000 Newton, whichever is the lower value. Additionally, there are some requirements according to losing connectors and connector safety devices. Based on these requirements, the following tests for hoses were defined. To certify a hose based on EN 1829-2, you have to do a leakage test, a change in length test, a cold band test, a burst pressure test, an impulse test, a tensile test, and a proof pressure hold test. What is a leakage test? A leakage test shall be conducted according to EN ISO 1402. Here, the test piece should be an unaged assembly, which isn't older than 13 days. The test pressure is equal to 70% of the specified minimum burst pressure. Here, we test the hose for 5 minutes, then we reduce the pressure to 0, and then we test the hose for 5 minutes again. If there's no leakage, the hose passed the test. The change in length test is also conducted according to EN ISO 1402. Here we test hoses for 5 minutes with the test pressure. Any change in length shall not exceed plus minus 2% of the original length. We also do a cold band test, and this is also specified in EN ISO 4672. Here, the hose have to be tested with a temperature from minus 10 degrees Celsius up to 2 degrees Celsius. During the test, the hose have to be tested with the minimum bend radius about 180 degrees. The testing time here is 24 hours. After the 24 hours, we do another pressure test, but in this case, in the normal atmosphere with an ambient temperature. If there's no leakage, the test is confirmed. Additionally, also the burst pressure test is specified in the EN 1829. Here, the test is conducted to EN ISO 1402 as well. Here, we increase the pressure until the hose or the hose assembly fails. According to the ISO, it's needed to document the position and also the mode of failure in the test report. For hose lines with maximum allowable working pressures up to 3000 bar, the safety factor, as I already said before, is 2.5 to 1. In hose assemblies with a safety factor over 3000 bar, the safety factor have to be 2 to 1. Here you can see a small animation from a bursting hose. Another test is the impulse test. This test is conducted according to EN ISO 6803. But based on the EN 1829-2, the hose have to reach minimum 20,000 cycles. The test pressure has to be at least the maximum working pressure. And the temperature of the medium has to be 70 degrees Celsius. The frequency is between 0.5 up to 1.3 Hertz. On the right, you can find a typical pressure test curve. Also, the tensile test is defined. Here, hose lines shall be installed in a tensile test machine. Hose lines shall withstand a tensile force equivalent to that indicated by a pressure equal to 1.5 times the maximum allowable working pressure, or 1000 Newton. Here you can have to test the hose with the lower value. Additionally, every hose assembly over 500 bar have to do a proof pressure test. So in the end, each hose assembly which leaves our facility is pressure tested according to the proof pressure test. The proof pressure on assemblies with a maximum working pressure smaller or equal 3000 bar is the working pressure multiplied with the factor 1.5. The proof pressure on assemblies with a maximum working pressure over 3000 bar is the working pressure multiplied with the factor 1.2. The testing time is between 30 seconds up to 60 seconds. Also, the marking on the hose is specified in EN 1829-2. Therefore, hoses have to be marked with the hose manufacturer's name, the maximum allowable working pressure, the nominal bore size, and the quarter and last 2 digits of year of manufacture. Also, the marking on assemblies is specified. Here, hose assemblies have to be marked or labeled with the hose manufacturer's name, with the maximum allowable working pressure, with the quarter and last 2 digits of year of manufacture, and with the number of the European standard, which is EN 1829-2. Due to the fact that we assemble and produce our hoses according to this standard, we try to reduce potential risks in hose applications. Now, Mr. Levin will inform you about ISO 23384.
Many thanks, Patrick, and for everybody who's joining the webinar, very welcome to the second part of the presentation, and this will be about the newly developed ISO standard. In fact, this one is not yet completed and not yet official. However, it is already on the FDIS, final draft of international standard stage. And I expect the standard to be completed and published in summer of this year. The name of the standard is, as you can see, not specially related to water jetting. It is for rubber and plastic hoses and hose assemblies, wire or textile reinforced types with working pressure equal or above 70 megapascal specification. This time, ISO did quite a good job in reducing the number of standards and appeared to take quite a practical and pragmatic way. In fact, the hoses which are used in water jetting industry are also used in high pressure hydraulics for example, bolt tensioners, which are in the meantime working with up to 3000 bar. And if you guys or your clients are asking us according to what standard tile hose is made, we can or we could refer to EN 1829-2. But as the bolt tensioner manufacturer or their clients were asking us according to which standard tire hose is made, we didn't have any answer because there was no standard. But these are exactly the same parts. We qualify them to exactly the same requirements, and therefore no two standards are needed. So, again, quite a pragmatic way, just one standard for both applications. Let's shortly take a look on the comparison between the ISO 23384 and EN 1829-2. There are quite a lot of same informations, as list of significant hazards, which is obviously not the complete one, but we are talking about the main foreseeable hazards only. The requirement, which Patrick also mentioned, that components shall meet each other, so it's never a good idea to put a SPIR STAR fitting on Parker hose or vice versa. Most of performance requirements are the same, and I will talk about the minor differences later. Obviously, each hose and each hose assembly shall be marked, and the requirements are also the same. And the requirement that each hose assembly shall be proof pressure tested is also the same, but here we come to the first difference. The targets of two standards are slightly different. The first one, the ISO, was driven by the hose manufacturers, and the idea was to specify more requirements for hose manufacturing, hose design, and hose qualification. As you see, that's specification for the hoses and hose assemblies. The EN standard is strongly related to the safety requirements. So even if there are a lot of same information in these two standards, there's also a few differences. Let's start with the ISO standard. That's for the first time that the pressure classes and diameters of hoses are defined. And there's also for the first time that hoses with 4:1 design factor are defined for this high pressure. As you see, I put this type A hoses with 4:1 design factor in a small letters here. They are not very important for us, for our industry. These are the typical hoses which are used, for example, on hydraulic rescue equipment, on fire brigades with their hydraulic scissors or rams or cylinders or something like that. All our products are the type B hoses according to the new ISO standard, and they all have the design factor of 2.5 to 1, with lowering the design factor in with higher pressure hoses. As you see, there are 7 pressure classes with 700, 1000, 1400, 2000, 2500, 3 and 4000 bar. Does it mean that you will never get a 1500 bar hose? No, it doesn't mean at all. These are just recommended pressure classes, and deviations are also acceptable. So it's no problem to get a pure, let's say, 15K hose or 20K or 40K. One thing regarding the design factor. I wouldn't say it's very important difference, but I think we've corrected here a small error which has been done in EN 1829-2. It was specifying the design factor of 2.5 to 1 for 3000 bar hose. which is technically not quite attainable currently. That's why all you know that you get the 3010 bar hoses, 3035 bar hoses, and you know that it all doesn't make sense in from the technical point of view. They all just have been done to overcome this nearly typing error in the EN standard. ISO does not specify it anymore, so if we are talking 3000 bar, according to ISO, 3000 bar hoses may be done. Quite a serious difference about the proof pressure test above 3000 bar. As Patrick already mentioned, on the hoses above 3000 bar, the current EN specification is to test the hose assembly at 1.2 times working pressure. The ISO standard puts the burst pressure as the main factor, and the test shall be done at 0.6 of burst pressure. Here's the example. The EN standard, typical 3000 bar working pressure hose, whether it's 3010 or 3035, doesn't matter, but we are talking in fact of 3000 bar pressure class. Those hoses have typically 7000 bar minimum burst pressure. According to the EN standard, they shall be proof pressure tested at 3600 bar. The new ISO says it's 60% of burst, and that will be 4200 bar. And this requirement is in fact very consistent, because all the hoses with working pressures below 3000 bar are tested at 60% of burst. Very easy calculation. 2.5 to 1 design factor, so it's then 40% of burst is the working pressure. By 1.5, it's 60% of burst. And these pressure test requirements, according to ISO, is now going through all pressure classes of the hoses, which means for you as hose assembly users, on the higher pressure hoses, you will get the hoses which are tested in the same way as the lower pressure ones. And there is a small deviation on the performance requirements of the hose assemblies. In fact, they are exactly the same with a small deviation regarding the tensile test. Why is that? Again, in fact, if we are talking about mechanical requirements on hoses or hose assemblies, they shall withstand the loads which are induced not only by working pressure, not only by 1.5 times of working pressure, but also the forces induced by burst pressure. So in this part, ISO puts the higher requirements on hose assemblies compared to the EN standards. And all the rest is exactly the same. A little bit more on safety requirements and protection requirements. In the EN standard, there's only the requirement for mandatory connection safety device. if your pump have above 40 kilowatt, or the hose assembly is above 500 bar. And on ISO, we didn't limit the protection measurements to connect a safety device only. The requirement is that the protection is mandatory, but the exact type of protection is not specified. There may be an additional protection hose over the main one, there may be bend stiffeners, there may be connector safety devices like Chinese fingers or something like that. And obviously both standards allow to omit the safety devices in justified cases. And justified cases would be typical tube cleaning, or if there are no persons which would be close to the hose assemblies. A few other things which are resulting from a little bit different targets of those standards. For example, in EN there are some additional safety requirements, like you have to have relief holes on the nuts, no wire lock nuts shall be used, you have to supply operating instruction with every hose assemblies, and so on and so forth. Exactly, also quite an important requirement that the hose assembly with exposed wires shall be removed from service. ISO does not specify these requirements, again, because the target of the standard is a little bit different, but it puts the length tolerances on hose assemblies, which is in most cases, again, not the very important parameters, whether it's 20 meters hose assembly or 20.1 or 19.9, normally doesn't make any difference, but there are certain cases where it does make difference, and then the specification will make these requirements clear. In addition, it tells hose manufacturers not only how they have to qualify their hoses, which type tests have to be run with the hoses and fittings, but also which production or routine tests shall be done. That means, for example, that a burst pressure test shall be done on each manufacturing bench of hose assembly, which is already the case, because obviously the high quality hose manufacturers do verify their products, but it makes the quality requirements for the manufacturers a little bit more clear, more stringent, and more demanding. What are the next steps, or how these standards will develop? In fact, they will be most likely, I'd say, like coexisting. As I mentioned, the targets of those standards are slightly different. The important thing is that EN standard is due for a periodic review, either this year or next year, and we as EWJI do have a possibility to take part in this periodic review and implement the changes to drive this standard more in the field of safety requirements, of maybe usage of the hose assembly, to get more differentiation to the ISO standard, which is more related to design and manufacturing. And that was the last slide of the presentation. Thanks for your attention.